Alright, let's look at the homework 6.1, problem number 5. Alright, let's sketch the region first. So y equals square root of x, and y equals 1/3 x, so that's going to be a straight line, and x equals 6, so that's a vertical line, 16. Right, so it looks like x equals 16. All 4 of them have it correctly. Alright, then if you look at the square root of x. At x equals 16, square root of 16 is 4. It's supposed to get 4. So first one and the second one is right, and let's see, third one is right, and but the fourth one is not right. So it's the first 3. Right. Then you look at 1/3 x. So 1/3 x. If you plug in 16, so it's going to be 5 point something. So 5.3333. So looks like this one is not right, and this one is way too low. Alright, so this is the correct picture right here. Alright, so once you have that picture, and maybe I'm gonna copy this, and then we can just set up an integral. Alright, so let's find the intersection. So we can see that the intersection starts 0, and we want to find that point there. Alright, so we're gonna have to set the square root of x equal 1/3 x. Alright. Alright, let's see, multiply both sides by 3. So you have a 3 square root of x is equal to x. And if you square that, you get 9x is equal to x squared. Right? So if you subtract the 9x from both sides, we get that 0 is equal to x squared minus 9x, which can be factored out as x times x minus 9. So it looks like x equals 0, which we already knew, and x equals 9. Right? So we know that this is going to be at 9. Right? So let's set up the integral. So integral would be a. So integral from 0 to 9. Top curve is square root of x, and bottom one is the 1/3 x. Right? With respect to x, and from 9 to 16, and top one is 1/3 x, and bottom one is a square root of x. Right? If you compute that, right, so this is you can rewrite this guy as x to the 1/2 power. So antiderivative would be x to the add 1 to the power, so 3/2. Divide by 3/2 is equivalent to multiply by 2/3. Right? Antiderivative of negative x over 3 would be x squared, and over 2, but the 3 is already there, so it's going to be 6. Then you're going from 0 to 9, right? And plus, right? So we're going to have antiderivative once we've done that, so it's x squared over 6, and a minus, and same thing, 2/3 x to the 3/2 power. Then you're going from 9 to 16, right? Then if you plug in 9, so square root of 9 is 3, cube is 27. Actually, let's say square root 27, but divide by 3, so that would be 2 times 9 would be 18. Minus, plug in 9, so you have, let's see, 81 over 6, which is equal to 27 over 2, right? And if you plug in 0, it's all 0, so I'm not going to write that down. So that's that. And here, if you plug in 16, so you have a 16, well, that's a big number, 16 squared over 6. I'm going to just, what's 16 over, let's see, 16 squared. I guess I have to do it. 16 times 6 times 6 is 36. And that's 6 to the 9, so 1, 6. So it's a 256. So 256 over 6, right, minus, right, it's a 2/3 times square root of 16 is 4, and a 4 cubed is a 64. All right, minus. All right, so if you plug in 9, so that's 27 over 27 over 2, and a minus, plug in 9, so it's 27 and 9, so 18. Minus 8, minus 18. Sorry, it's getting messy here. All right, so we have that. Then we just have to simplify this expression, and this is going to be, all right, so how do we simplify? So we have 18 here, and negative 8, so it's positive 18, so the combined you have 36, and then you have negative 27 over 2, and there's another negative 7 over 2. Okay, let's see why it's getting good. That, so that would be negative 27, right? And then we can cancel, so this is going to be 3 and 128. All right, then you have another 128 over 3. Actually, luckily we can cancel this guy and that guy. All right, and that's everyone. So this is going to be equal to 9. All right, so let's see if this is correct. And oops, that's not the right one. And here, area is 9. Right. Let's submit for testing. Alright, I came back. It looks like we got the correct graph and the correct area. Alright, that's it. I hope that this was clear.